Good evening, everyone. So today I'll welcome you to the class in which we'll learn numpy library. Okay. So the same format we'll follow. To learn any library, the best way is to go to its documentation. So for its documentation, okay. So going to its documentation, we'll type this numpy and documentation. Numpy documentation. Okay. So the documentation provided by numpy is, so we'll start from its probably manual or the web. Okay, so first of all, what is numpy? Who uses it and why? Numpy is the fundamental package for scientific computing in Python. It is the Python library that provides a multi-dimensional array object, various derived objects, and an assortment of routines for fast operation on arrays. Okay, so the basic thing that we have to learn is that it is a Python library that provides multi-dimensional array objects and etc for the fast operation on arrays. Okay, so the main intent with the Python is its fast operation on arrays, on all the objects basically. Okay, so at the core of numpy package is the nd array object. Okay, this encapsulates the n-dimensional array of homogeneous data types with many operations being performed in the compiled code of performance. Okay, so this is all about the numpy arrays, and I'll really suggest you to go through all of the theory. Okay, so here first of all its installation. So we can install it via conda install numpy or simply pip install numpy. Okay, both way it would work. Okay, so the one thing is conda install numpy. Okay, since we have installed anaconda navigator in a system, so it is perfectly fine that we have conda over here. So conda, we assume that we already have. We just have to type conda install numpy or pip install numpy. Okay, either you can install it via conda or via pip. Okay, so and all the next things you can go through it. Numpy quick start, and okay, so this is the basics and a really very good documentation to go through it. Okay, so let us start with the notebooks that okay. Okay, so with the numpy here, cmd Jupyter notebook. Okay, so first of all we'll see numpy arrays. Okay, we have seen why we're going to use the numpy library for the fast execution. Okay, so uh, our basic purpose is that it gives us so many facilities to do so many operations, and apart from that it is really very fast. Okay, now numpy is a linear algebra library for Python. The reason it is so important for data science with Python is that almost all libraries in the PyData ecosystem relies on numpy. Okay, so basically all many of the mathematical libraries rely on the numpy for its base library. Okay, means those libraries are using the function provided by the numpy library. Okay, so now why the numpy is incredibly fast? Why it is fast? Because it has bindings to C libraries. Okay, so in the very first class of Python we have discussed that Python didn't get that much attention at the starting because it was the slow language. Okay, later when we had the amazing computing power, then the Python was preferred. Okay, so now how numpy is fast? Because numpy has the bindings to the C libraries. Okay, in the very first lecture we have also discussed that the Python project can is extendable. Okay, so it can have the other files which are written in different languages, C, C++, Java, and all that. Okay, so fine. And for the installation, it is you can write it via conda install numpy or pip install numpy. Okay, so fine, it is I already have numpy installed in my system, so that's why I'm not going to install it again. And okay, so okay, so let us start it from here. Let me just clear it once. Okay. So the first step is always to import the library whenever we are going to use any library. So we need to import that. So we'll import numpy as np. Okay, fine. It has been imported successfully. No issues in that. Okay. So now numpy has many built-in functionalities and capabilities. Important important aspects are Important aspects of NumPy are vectors, array, matrices, and number generation. Okay. So first of all, we are going to focus on the NumPy arrays. Okay. Now, okay. So first of it has many built-in functionalities, but the first thing we are going to focus on is the NumPy arrays. Okay. So I hope you know the difference between the vector and matrices. Okay. This is not the vector, the one which we use in the physics one, which have the direction and the number associated with that. Okay, the value associated with that. But here in mathematics, the vectors are the 1D array. Okay, 1D array, one-dimensional array is known as a vector, and two-dimensional arrays are known as matrices. Okay, so 1D arrays are known as vectors. 1D, one dimension, we just have either a row or a column. 1D, then it is known as a vector, and the 2D, where it is 2D, so it is the matrix. Okay, so but you should not say that a matrix can still, okay, but it is possible that matrix can still have only one row or only one column. Okay, it is not mandatory for a matrix to have more than one row or more than one column, but this is a general definition that vector is a 1D array and matrices are 2D array. Okay, so and above than that, there are tensors, which we'll discuss in the further classes. Okay. So first of all, how we can create the numpy arrays. Okay. So the first way is, okay. So our objective for quite a time being would be to create the numpy arrays. Okay. We'll see different ways of creating the numpy arrays. First is from a Python list. We can create an array by directly converting a list or list of lists. Okay, so going to step by step. Okay, I'll execute this statement step by step. First, I want you to pause the video and tell me what this, just write it somewhere or just have it in your mind what each of the statement is doing. Okay, we have covered all of them. Okay, in the line number 1, I would request you to pause the video and write it somewhere what these instructions are, what these line segments are doing. Okay, in line number 1, we are creating a list of three elements. Okay, we are just creating a list of three elements and storing in the variable mylist. In line number 2, we are searching the type of the mylist. Okay, type of the variable mylist, that is obviously going to be the list only. Okay, in line number 3, okay, now this is something separate. We need to see something separate. So the s is 10. Okay, this is a string. Okay, s is a string. Now if I write a is equal to int of s, okay, int in the braces s, what is being done over here? It is converting the string to the integer. Okay, it is converting the string to the integer. Now if I print the type of the a, what it will give me? It will give me an integer, of course. Okay, now this step is known as typecasting. Okay, this step is known as typecasting. A is equal to int of s. This is typecasting. Similar to it, very similar to it, what we are going to do, we have the list, my list. So to convert it to the numpy array, okay, so we install numpy as np. So np.array, np.array my list, what would it give me? It would give me it will give me the array, numpy array of convert, means the values of this list get converted to the numpy array. Okay, so this is known as a typecasting. We can typecast from one data type to the another one. Similarly, very simply, what we are doing, we are taking a list, a single list, okay, non-nested list, basically simple list, and converting it to the numpy array. Okay, converting it to the numpy array. Now it will give us the 1D array. Okay, 1D array also known as vector. Perfectly fine. Now let us go to the next one. So here what we are doing is, here we are having the nested list. Okay, basically list of lists, a nested list. Okay, what is being done over here? It will matrix is the, till now it is just the list of lists, or basically when I type the print, I'll print the type of this my matrix. It will just give me a list. Okay, print type of the my matrix. Okay, print type of the my matrix. Okay, so it is just simply a list. Okay, it is just simply a list. Okay, and this is just a list, but we know it is a list of lists. Okay, so now if I have to convert it into the numpy array, if I have to convert this my matrix variable into the numpy array, it will give me the two-dimensional array. Okay, it will give me the two-dimensional array. Perfectly fine. Okay, let us revise what we have done till now. First of all, we have to import the library. Sorry. First of all, we have to import the library, and then okay. So first, what we have done, we first imported the numpy library, okay, as the alias. This np is the standard name taken for the numpy. If you want to give any other name, it is perfectly fine. Okay. So first we are doing importing the numpy as np. The first way of creating the numpy array from a Python list, okay. From a single list, we'll create, okay, single list, my list. We can, when we'll convert it to the numpy array, it will become the 1D array, okay, one-dimensional array, also known as a vector. Next is we had the list of lists, a nested list, and then when we are going to convert to the numpy array, it will be having the 2D array, okay, a 2D array, okay, matrix or a 2D array. Perfectly fine. Now let us see. Okay, there are multiple ways to generate the array. Okay, so we are going to cover very few of them. Okay, too few of them, and for starting purpose, they are more than sufficient. The first one is a range. Okay, so the first one is a range. np.arange 0 to 2. What it is going to do? Okay, whenever we are going to do any function, we are going to see any function. What we'll do? Go to the keep the cursor over there and type shift tab. Okay, shift tab. Okay, now very clearly understand, it returns evenly spaced values with a given interval. Okay, evenly spaced values with the given interval. Okay. So for some of them, they have given the examples also. Okay, so basically what it is going to do, it returns evenly spaced values within a given interval. Okay, so the first parameter is start. Any parameter that is enclosed in these rectangular brackets is optional. Okay, it is optional. If we give it, fine. If we don't give it, then also see, if we give it, is optional. So if we give some value, then perfectly fine, it will start from there. Otherwise, and it is inclusive. Okay, the default start value is 0. If we don't give it, then the start value it will take as 0. Okay, now the next one is stop. Stop doesn't have any default value, and neither it has a default value, nor it is optional. So we mandatorily have to give at least one parameter. Okay, stop. Let us have the stop is the interval, and where the end of that one. Okay, and it is not inclusive. Okay, end is exclusive. Okay, so, and in some cases where step is not an integer and the floating point rounds off and affects to the length of out. Okay, in that case it can become that number, the last one, but otherwise the last is always exclusive. Okay, in case some cases that there might be means it just rounds off and become like that, then the last can become like that, otherwise the end is exclusive. Okay, the next parameter is step. Okay, it is step, it is also optional. If we don't give anything, then the step size is 1. If we give something, then it is that. Okay, now let us see examples also for this. np.arange 3, we are given only one parameter, so it will go to the stop. Okay, now 3 would become the stop. Okay, start by default 0, step by default 1, so 0 1 2. Okay, similarly, if I give 3.0, then it will give the float values 0 1 2. Okay, now if I give the two parameters, okay, now if I give the two parameters, the 3 would corresponds to the start and 7 would corresponds to the stop. Okay, 3 corresponds to start and 7 corresponds to stop. Okay, so 3 4 5 6 would be the output, obviously, because the end is exclusive. Okay, now the next one is, we are giving the three parameters. Okay, we are giving the three parameters, so one would go to start, second one to the stop, and the third one would go to the step. Okay, so starting from 3 and step size to be 2, it becomes 3 plus 2 is 5, then it will become 5 plus 2 is 7, and 7 is to be exclusive, so it will not include that. Okay, very clear with the np dot range and 0 comma 2. Okay, So we have discussed a plenty of things about this A range. Now I would like you to pause the video right here and on some pen paper, just write its output. Okay, pause the video over here and write whatever output do you think it should have. Okay, so after you continue, so we are sending two parameters. So the first one would go with the start and the second one would go with the stop. Okay, so starting from 0 and stopping at 2 with the step size 1. Okay, it will become 0 1. Okay, it will having the value 0 1. Okay, similarly in the next one, 0 12 2, we are sending three parameters. So the start is 0, stop is 12, and the step size is 2. Okay, so it would become 0 2 4 6 8 so and 10. Okay, fine, clear. Now, the third one is starting from 30 and ending to 0 with the minus 3 step size. Obviously, it will become 30, 27, 24, so on to 3. It can't be 0 because end is to be exclusive. Clear? Now, the next one is 0, 44. It will start from 0 and keep on adding 4 till the 40 comes. Okay. Very simple. Fine. Okay. Now, let us go to the next one. If we want to generate the arrays of zeros or ones, okay, let us go to this function and see its doc string. So it returns a new array of given shape and type. Okay, it returns a new array of given shape and type. Shape, here is the dimensions of the array you want. If you give the single value, it will create the one dimension array, and if you will give the two dimensional two values, okay, the one it will goes to row, number of rows, and the other to column. Okay, now D type is the data type, what kind of data you want to fill in here. Over here, example, numpy.int 8. Okay, default is numpy.float 64. Okay, now the third parameter is order. Okay, you might have heard about the row major and the column major. Row major and the column major arrays. Okay, in the row major, what happens? In the row major, what happens? The values are stored in the form of rows first. Okay, I'll show you over here. So uh, give me a minute. Suppose that this is my table. Okay, in the row major, how the values are going to be filled? 1, 2, the values are going to be filled like this: 1 2 3 4 5 6 7 8 9 10 11 12. This is for row major. Okay, the means the values that are being over in that they're going to be filled like this. Okay, the memory it will be having would be consumed like this. Okay, for example, the one is stored at some value in the memory at 80. Okay, and it is consuming 2 bytes. So the another one at the 82, this would be having the value. Okay, in the memory 84 this would have, and 86 this would have the value. So the next 5 would have the value 88. Okay, so this is going to be helpful in the case when we have to find the when we have to extract the information row wise. Okay, for example, let us consider this table of having the values serial number, name, age, and salary. Okay, serial number, name, age, and salary, and over here we are having the person like Ram, Sham, Geeta. Okay, now in case I have the my program wants to have the detail of Ram. Okay, if my program wants to have the detail of Ram, so it would be useful to store it in the row major form. Okay, because the memory that are having stored closed, they are easy to fetch. Okay, easy to fetch. Okay, for example, see, let me complete this first. 88, 90, 92, 94, 96, 98, 100, and 102. Okay. For example, in this case, this is a row major, and I want to find the details of Sham. Okay. So now my memory can easily fetch the details of 80, 90, 92, 94, so on. Okay. But in case I want to find the name of all the name of all the people, okay, name of all the people, then my memory, first I have to search at 82, then I have to search at 90, then I have to search at 98. Okay, that would increase my computation and would waste my computation basically and increase the time. Okay, so it depends upon what kind of program we are going to what objective of the program is, what kind of things we have to work on it. So what a row major would be fine, or column major would be fine. Okay, in fact it would have been a column major. Okay, for example, it would have been in the column major. Then its value would be 80, 82, 84, 86, 88, 88, 90, and so on. Okay, now if I have to find the name, now it is fetching is very easy. Okay, because if the values are, if they are stored, values are stored near to each other in the memory, then it becomes easy for them to extract. Okay, clear? So this is the column major and earlier one was the row major. Okay, so let me shift to the other screen. Okay, so now we just want to generate the arrays of zeros or one. Okay, so this is, we have to give the dimension. Okay, so now if I give one, if I want a vector, basically vector with the three values, so it is 0 0 0. Okay, now 5 5 5, it will give me the array of the dimensions 5 cross 5 cross 9. Okay, so it will give me 5 cross 5 cross 9. Okay, fine. Now, similarly, if I want to create the array of ones, so this is my function, and to create a 2D array of the dimensions 3 cross 3 and having all the ones, it is this. Okay, clear? Pretty simple till now. Okay, yeah. Now let us go to the next topic. Linspace. Linspace function, it returns evenly spaced number over a specified interval. Okay, it returns evenly spaced numbers over a specified interval. Okay, let us go into its the doc string. Okay, why I always read from the docstring is, for example, if you encounter any new method, okay, any new method, or in fact, when you will come back after some time, there's a possibility that we might not remember these functions, okay, what these functions are doing, or there may be some confusion. Okay, so you never feel a pressure of learning everything or keeping everything in mind. Okay, always go to the docstring, make a habit before using it, go revise the docstring just once, and then uh, things become very easy. Okay, over here the arguments are, see, now start and stop, neither they are optional nor they are having any default value. So when we are going to call this linspace function, we definitely have to call the start and the stop function. Okay, we definitely have to give the parameters, the values to the start and stop. Okay, so next is the num equal to 50, endpoint true, reach, we'll see all the things. Basically, start and stop, it is perfectly fine, but the start and stop is going to do. Okay, now there is one more thing. We have seen in all the cases till now, the end is exclusive. The end is exclusive, but in case we want the end to be included. Okay, yeah, see, endpoint. If true, okay, if true, stop is the last sample. Otherwise, it is not included. Okay. If true, stop is the last sample, means the stop point is going to be inclusive. The stop point is going to be called. Okay. But if not, means if it is false, if the endpoint is kept to be false, then it will be exclusive. Okay. If endpoint is true, the 10 would be included. In this case, endpoint is false, so 10 would not be included. Okay, and the parameters is start and stop, we have seen, and the number is number of samples to generate. By default it is 50. By default it is 50, and obviously it must be non-negative. How can you generate -5 numbers? Okay, you can't generate -5 numbers. You can either generate 1 or 2 and so on. Okay, or you can generate 0 also, but not any negative number. Okay, so fine. Now here we are just giving start and stop and endpoint. We are not giving the num, so it will generate 50 numbers equally spaced from 0 to 10. Okay, giving 10 as exclusive, because we have said that endpoint should be false. Okay, now see this. Okay, pause the video. Just write on a piece of a paper, what it is going to do, and then continue the video. Okay, so this is going to generate the three numbers equally spaced from 0 to 10, keeping 10 as inclusive. Okay, so it is 0, 5, and 10. Okay, perfectly fine. So the difference means these numbers are basically in AP. The difference between 5 and 0 and 10 and 5 would be same. Okay. Here also the difference between all the numbers would be same. Okay. Basically, the numbers are in the AP, arithmetic progression. Okay. Now, clear? Now the next thing we are going to see is the identity matrix. Okay. We know the in the 11th and 12th, since every one of us have done it in non-medical with the math, so we know the importance of identity matrix. Okay, we know the importance of identity matrix, where we are going to use it in calculating the inverse, in doing so many computations. Okay, the main purpose is to calculate the inverse of the matrix. Okay, so to create an identity matrix, what it is, np.if, what it will do, it returns a 2D array with ones on the diagonal and zeros everywhere. Okay, so n is the n is the number of rows for the identity matrix. Number of rows and number of columns are going to be same. Okay, and okay, so np.a, it would give me the 8 cross 8 matrix with 1 on the diagonals and 0 otherwise. Okay, pretty simple. Yeah. Now the next is very interesting thing. NumPy also has lots of way to create the random number arrays. Okay, we just like we don't have to fill the values inside that. It'll automatically fill some values from random values. Okay, the first one is rand. Okay, it creates an array. It creates an array. Okay, just give me a minute. Import. Okay, so we need to import it also. Okay, and where the import is. Okay, so NumPy has a lot of ways to create the random arrays. The with the rand, what it is going to see over here. If I type Shift Tab, so here inside it, it is the dimensions. Okay, it is the dimensions. What it is going to do, it is going to create an array of the given shape and populate it with the random samples from a uniform distribution. Okay, these are the mathematical term. From the uniform distribution, it is going to create an array of the given shape, the shape whatever we give. Okay, so here the examples are also given. For example, 3 comma 2. Okay, with the 3 comma 2, it is going to create an array of the dimensions with the 3 rows and 2 columns, and the values are stored in here with the uniform distribution. Okay, so keeping 0 as inclusive and 1 as exclusive. Okay, so np.random and 10, it will give me the 1D array having 10 elements in it. Okay, 1D array, 10 elements in it. 2 comma 2, just pause the video and write it on a piece of paper. What it is going to do, it is going to create the 2 cross 2 2 cross 2 array of array populated with a random distribution, random uniform distribution numbers. Okay, now the next one is similar is random. It returns a sample from the standard normal distribution. Okay, same, we are going to fill the dimension in it, and the rand and n is going to return a sample of normal distribution. Okay, so here with the 2 1 1D array with the 2 elements, and 5 cross 5 is the array with the 5 rows and 5 columns. Okay, similarly it is rand int. Okay, now it returns random integer from low to high. Okay, low is let us see read its documentation. So here you can see the parameters that are required is low is mandatory. Okay, low we have to give. Okay, so first of all, it is going to return random integers from low to high. High is none by default, or whatever we give it. Okay, size is equal to none. If we don't give anything, then size is, if you don't give anything, then size is it will give, or it will return only 1. Now this one is to print the random numbers from 1 to 100, and one random number from 1 to 100, one random integer from 1 to 100. Okay, this is 10 random integers from 1 to 100. Okay, so now this is a question to print 20 random values from 23 to 45. Okay, so n is going to be exclusive, so we can write 23, 46 and 20 as the how many values we want. Okay, clear? And okay, if you have any doubts, if you encounter any doubts, you are always feel free to contact me via support team. Okay, the next one is, Okay, now we'll see few of the attributes. Okay, okay, pause the video over here and tell me what these two lines would do. Pause it and write it on a piece of a paper. What these two lines are going to do. So the line number one is going to create an array of one dimension with 25 elements. Okay. Now, if we want to check the shape of the array. Okay, we want to check the shape of this numpy arrays. So what we can do, arr dot shape. Okay, arr dot shape. So dot shape is the attribute. Don't write these function parentheses after that shape. Okay, it is 25 comma nothing. Okay, it is not 25 comma 1. If it would have been 25 comma 1, that would mean that there are 25 rows and one column. Okay, it is 25 comma nothing. It means there is only one row. There's only one row and having 25 elements in it. Okay, so it is basically a vector having 25 elements in it. Okay. The next one that we have created is Rn ARR. It is going to create 10 random integers from 0 to 50. Okay, 50 being exclusive. Now, if we want to reshape our data, so first of all, what we have is ARR1 dot shape. Okay, let us see. We know what is the shape of ARR. We know what is the shape of ARR that we have just search over here is 25 comma nothing. Okay, if I want to reshape it to 25 comma 1, okay, now it will become 25 rows and one column. Now if I'll print this reshape, so now the shape would be 25 comma 1. This means 25 rows and one column. Okay, so now I can do it with the any factor of the 25. Basically, if I want to have it with the 25 comma 5, 5 comma 5, then it will become its shape would become 5 comma 5 also, and the dimension and the array would look like this. Okay, similarly, if I try to do it with some number that are not the factor of the 25, for example 12 and 13. Okay, 12 and 13, 12 and 13, these are not the factors of 25. Okay, so then it will give me an error. Okay, cannot reshape array of size 25 into the shape 12 13. Okay, so it has to be some factor of the 25 only. Okay, if I do 25 comma 1, that will perfectly work. Here it is 25 comma 1. Okay, or either I can do like this also, 1 comma 25. Okay, 1 comma 25, 1 comma 25. So it means a one row and 25 elements. Okay, one row and 25 columns in it. Okay, okay, there are some useful methods. Okay, we'll very quickly go through it. There are some useful methods for finding the minimum maximum values. And first is, let us see what this R1 R array looks like. It is having some 1 2 3 4 5 6 7 8 9 10 values. Okay, so 10 values. If I want to find the maximum, okay, let us go to dog string. It returns a maximum along a given axis. Okay, it returns the maximum. So the maximum is 47. Argmax would return the location of the return the indices or the location of the maximum values. Okay, the maximum value is 47. That is at the position number 7, starting from 0, 1, 2, 3, 4, 5, 6, 7. Starting from 0, its position is 7. So it will give us this. Okay, similarly, to find the minimum value, we have r1 and arr dot min and the argmin for the location of that. Okay, clear? No doubts? Then we have the shape is an attribute that array have. Okay, arr is this, and arr dot shape that we have just seen, and reshape also we have just seen. Okay, so okay, so if you have any doubts regarding any topic, always feel free to contact me. Okay, okay, this is the next file. If the previous all the things are clear, now we'll see the numpy indexing and selection. Okay, so similarly, this indexing and selection is very simple, and the same way that we have done with the list and with the strings. Okay, why I took a whole time in the strings to do that, for the reason that it is going to be used extensively. Okay, so first of all, new program, so we need to import the library again. Now this is going to create me the array of 10 numbers from 0 to 10. Okay, of 10 numbers, of 11 numbers, basically 11 numbers from 0 to 10. Okay. So now if I want to find a value of particular index, if I want to get a value at particular index, then array of 8. Okay, what is at index 8? It will give me 8. Okay. So in fact, I would suggest you to pause the video over here and try them first. Okay. ARR 1 to 5, from index 1 to 5, it will give me these values 1 to 4, and from 0 to 5, it will give me from 0 to 5, 0 to 4. Okay. Fine. Now, the one interesting thing. Okay. For For indexing and slicing, I think we have done lots of practice in the strings part basically, and then a little in the list part. So it is perfectly fine over here. Now we see with the broadcasting. If we see with the broadcasting, numpy array differs from the normal list because of their ability to broadcast. Okay. Now see it here very, very clearly. See, our array is, this numpy array is having 11 values from 0 to 10. Perfectly fine. Now if I do this array and from 0 to 5, okay, from index 0 to 5, the values I want to fill in them are 100. Okay, so now from 0 to 5, from index 0 to 5, 5 is exclusive. Okay, 5 is exclusive. So from 0 to 5, 5 being exclusive, the value would be updated to 100. Okay, the value would be updated to 100. So now let us see one more thing. Let us create a new numpy array having 11 values from 0 to 10. Okay, now if I slice it, if I want to create the another numpy array, if I want to create the another numpy array having the first having the values from 0 to 6, having the values from index 0 to index 6 of this array. Okay, so I can create it very easily. Okay, slicing like this. Now see it very, very carefully. If sorry, the new array that I'm having is, I'm updating the value to 99. Okay, so this is the new array, slice of array having 6 elements from 0 to 5. If I'm updating all its value to 99, if I'm updating all its value to 99, so now my array would become like this. Perfectly fine. That is fine. That is seen. But now let us see, the change has also occurred in our original array. What we have done, let us see it from the starting. We created an numpy array from 0 to 10. Okay, from values 0 to 10. We created another numpy array by slicing, having values of index 0 to 6 from this original array. Okay, we made some changes in the new numpy array. Those changes are reflected in our original array also. Okay, so actually data is not being copied, it is a view of the original array. So this avoids memory problem basically. So in case we want to create the different copies, we can create it like this. Array copy is equal to, means the new array should be old array dot copy. Okay, new array is equal to old array dot copy. Okay, then it will be different copies. Then if you make change in one of the arrays, it will not be reflected in the another one. Okay, so yeah. Now if we want to have the 2D array, okay, so the indexing is simple. If we want the first row, so ARR 2D 1. Okay, if we want to get the element from that, okay, 1 0 means from the first row, the 0th element, means from the row corresponding to index 1, the 0th element, that is 20. Okay, you can see it over here, perfectly fine. So it can be written like this also, 1 comma 0. It can be written like this also. Okay, now if I want to find, like, this is a slicing for the, what is before comma is for rows and what is after comma, that is for column. Okay, this is a simple slicing. We have seen it for so many times. If you want to shift bottom row, so it is like this, and if we like this also, okay, means empty column. If we take, it will take all the whole row. Okay, fine. Now there is something more known as fancy indexing. Okay, fancy indexing, it is the topic little complex. So it allows us to select the entire rows or column out of order to show this. Okay, so basically it allows us to select entire rows or columns out of order also. Okay, now very quickly see what this np.zeros is going to give me. A 10 cross 10 array all filled with 0. The 10 cross 10 array all filled with 0. Now what this was going to give me, arr2d dot shape 1. It will give me the length of array. It will give me the length of array. Length of array is how many columns, how many rows we are having in it. Okay. So now, if we set up an array for I in range, for I in range 10, okay, so this loop would be executed 10 times. Each time, okay, it will be executed for first 0, then for 1, then for 2, so on to till 10. Okay. Then all the elements in that row, in that particular row should get that value. Okay. Let us see. It becomes like this. Okay. Now, if we want to print, this is just a way of creation the array. Okay, this is nothing linked with the numpy basically. This is how we are going to just create an array. Different ways and different computations that can be done over here. Okay, so if we want to print the uh, row 2468, so we can print it like that. Okay, and it allows us to print in any random order also. In the random order also, it is perfectly fine. Okay, so it might be confusing for a while, but once you practice it yourself, it will become more clear. Okay. Now, so the another one is the selection one. So if let us create a new array with the 10 10 elements from 1 to 10. Okay, we have created a new array with the elements with the 10 elements from 1 to 10. Okay, now see it very nicely. ARR greater than 4. ARR greater than 4 would give me, wherever the condition is true, it will give me true, and wherever the condition is false, element wise, it will give me false. Okay. Now, if I want to create a new array, okay, if I want to create a new Boolean array like this, so my Boolean array is this. Okay, this is the new array. Okay, the new number array that we have created is like this. Okay, now if I do like this array inside this Boolean array, okay, inside this Boolean array, so it will wherever it is true now, wherever it is true, that number from this array would be printed. Okay, so what we are, if we would have typed the whole array, okay, if I insert one cell above, if I would have executed all, it will be printed. If inside the braces I put this Boolean array, then wherever it is true, those values would be printed. Okay. So if I want to, if from the original array, if my objective is to find the values greater than 2, I can just like write like this. Pretty simple. So my objective is from the array, if I want to find the elements greater than 2, I can write like this. Here, if I want to write, if I want from the user, I want to take some input and then store it over here. If from this array, if I want to print the elements that are greater than it, here it is here. Okay. Quite simple and really interesting, I hope so. Okay. So then this is numpy operation, a little small topic, but let us cover it. Okay. So mm, let us create a new, first of all, new file. So we need to import it again. So first of all, I create a new array with 10 elements from 0 to 9. Okay. If you want to add two array to these two numpy arrays and then store it in the another one, so it will become like this. Okay, so elements means element wise it will be addition would be done. Similarly with the multiplication, element wise multiplication would be done. Okay, minus also element wise it would be done. Okay, so now there's one thing. If we do 5 by 0, it will give us an error that it is division by 0. Okay. But in this case, this ARR1 is all zeros. ARR1 divided by ARR1. Element wise, it is going to be divided like this 0 by 0, 0 by 0, 0 by 0. It will not give us an error. It will not give us an error, but it will give us the warning. Okay. Invalid value encounter and true divide. But it is not giving the error. Okay. Means in case this thing arises in a program, then a program would not abruptly shut down. Okay, with this it will abruptly come to the halt, but with this it will not abruptly come to the halt, and it will just store the values, nan values. Okay, not a number. Okay, so like 1 divided by ARR, that is having the 0, where it is 0, it is having the infinity. Okay, it is already giving us the warning, but it is not shutting the program down. Okay, ARR 0.5, and wherever we have the values, we will get the squares of that. Okay, or square roots of that, basically square roots of that. Okay, so there are few functions, like square root array. It will find the square root of all the functions. Okay, so let us go to the shift tab. So basically what it has to do, it returns the non-negative square root of an array. Okay, basically it returns the non-negative square root of an array. Okay, and element wise. Okay, so whatever we have in the array, okay, whatever we're having in an array, In the array, we are having these 10 values from 0 to 9. This np dot square root arr would return the non-negative square root of an array, okay, element wise. And the uh, parameters that we have to pass is the x, the array, like, okay, the values whose square roots are required, okay, means we want the square roots of the elements of arr, so we are sending arr over here, okay, and then out is the nd array, okay, and all these if we want to give. So here examples are also there. So if I write like this 149, so for 149 it will give the square root. For 1 it is 1, for square root 4 it is 2, and the 9 it is 3. Okay, so for the complex numbers also we have seen. See, for the minus, for the negative number, the square root, it is means the square root, the response is nan, okay, not a number. Okay, so this is the square root, we are only going to count for the non-negative numbers. Okay, if this is the infinity one, so square root of infinity also it is infinity, so it will do same thing. Okay, so fine with the square root. Next is the exponential. Okay, so with the exponential, what it is going to do is it calculates the exponential of all elements in the input array. Okay, all the inputs in the input array. Okay, so same thing, same it is array like, and all the parameters are same. Let us see the examples. X np equal to length space. First it will create that. Okay, first it will create that, and then it will have it. Okay, so the examples are a little complex. Let us not go that. So with that array, so it will give us the exponential with that. Okay, so now if I want to find the arr.max and np.max is same. Okay, but these are just the functions provided by the numpy. So here, see, now a is the required one. We definitely have to give the parameter a to it. Okay, for the other parameters there is some default value. It returns the maximum of an array or maximum along an axis. Okay, so here we see the examples. It is always good to go through the other things also, other parameters also, but let us see the examples here only. So first of all, they have created a numpy array of with the a range 4 and reshaped to 2 comma 2. Okay, they created this becomes our array. Now np.amax. Okay, uh why have they have written amax? Okay, so np.amax is a. Probably amax should not be working. Okay, so amax is also working fine, good. So you can see over there the functions amax, and it will give you the maximum value. Okay, it will give you the maximum of that. Okay, so that also the max is also working, and amax is also working. Okay, max and amax both are working, and this is basically the array.max similar one. Okay, so now if we want to find the sign of all the element wise or log of all the element wise, we can do it via this. Okay, so this was all about the numpy arrays, and let us just revise everything. Okay, to revise, the first thing we have done is we have installed the numpy library, and then we are going to import it. Okay, so we can create the numpy arrays using the Python list or list of lists. The list would give us the 1D array, and the list of lists would give the 2D arrays. Okay, and so on. The A range would give us evenly spaced values. Okay, so here the one are the parameters that we are definitely going to give is the start, means they are optional, but it is good to give a start, stop, and the step size. Then we can generate the zeros and ones array. Okay, then we can create the array using the length space and the parameters with the start and and the number of elements we want. Okay, then we can create the identity matrix. Then we can create the array using rand n and rand end. Okay, and then there is to how we can reshape it. We can reshape the array also. The another one is the few functions are max, argmax, min, and argmin. Okay, to find the maximum and minimum value or the location of that maximum or minimum value. Perfectly fine. In the next one we have seen basically the indexing and slicing. Okay, how we can see is the indexing and slicing. Then we have seen the broadcasting. Okay, and then if we want to make if we want to make a new array from the previous one, or need a different copy, so we can choose among them. Then the indexing and slicing is pretty simple. Then with the fancy indexing, it allows us to select the entire rows or columns, and that also out of order. Okay. Basically, fancy indexing is just this thing. Okay. Basically, fancy indexing is just this thing. The one that we have done a computation over here, it is just the simple computation. Okay. This has nothing to deal with the fancy indexing. Okay. So then we had we had seen this example, and then the last one we have seen arithmetic operations on the numpy, and then a few of the functions that we can operate over these over the numpy. Okay, so thank you everyone. For any doubt, feel free to contact me. You can anytime contact to this mail to the support team, and they'll forward your doubts to me. Okay, so thank you everyone.